Hi, in this video I'm going to demonstrate the Mission Planner software on a basic level. I do encourage you to look over the documentation that is linked on the same page to view everything that is available with the program. You can also find a download link to the Mission Planner software on this same page so that you can try all of the things that I'm demonstrating in this video for yourself without actually having the UAV in your hands, just to get a feel of how things work. The first thing you will see when you open up the Mission Planner software is some of the flight parameters that are available for viewing things such as telemetry information, altitude, distance to next waypoint, ground speed, and so forth. However, most of these things are not necessarily going to be useful to you on an everyday basis. What you are going to be using every time you go out and fly is your Flight Path tab here, which allows you to set up a flight path for your UAV when you want to go out and collect your images for image processing, aerial photography, or other similar applications. The first thing that you're going to want to do is zoom in to your area of interest. This is just a standard farm in Iowa that I've picked out. You can see zoom in and out here, and choose a map that you would like to survey here on the right. You can also use a Google Street View map to first do your analysis and then go to the satellite map to better analyze what you're looking for the purposes that you need. In this video, though, I'm just going to demonstrate the function of creating an autogrid for photo stitching or photo analysis and creating DEMs and ortho maps and so forth, or for creating NDVI imagery or near-infrared image maps for crop monitoring. So, now that I have my point of interest and am ready to get started, the very first thing that I'm always going to do is to tell the flight planner that I want to program in an automatic takeoff waypoint. You can also use the manual control of the hardware through the included RC transmitter to take off in manual mode if you wish. However, this is generally for more advanced users, and most of our customers prefer to simply use the program's automatic takeoff function. To do this, right-click on the map and select Takeoff. Then tell the UAV what threshold altitude you want the automatic mode to engage in. In the case of using our bungee launcher, you would want to choose about 10 meters, while for a hand launch you would want to choose about a meter. From there, click OK and confirm that the 15 degrees of takeoff inclination is OK as well. We'll stick with that every time. You can see here in the Waypoints menu that we have a takeoff command programmed in at 10 meters in altitude, and when the UAV hits 3 meters per second in velocity and 10 meters in altitude, the automatic mode will take in and the UAV will fly through all of the predefined waypoints that have been programmed into its memory, which we will set up right now. So once you've synced the UAV with the ground station control software, all of the waypoints will be programmed in the UAV's memory automatically, and will stay programmed in even without a direct link to the UAV. Now to fly an autogrid pattern with the software, right-click and select Draw a Polygon Point at each corner of the area that you want to monitor. In this case, it's a square mile of this farm. You can move these points around afterward if needed. So once you've done that and have a bounding box set up, right-click and go to Auto Waypoint and select Survey Grid. Now the program will suggest a flight path for you and will tell you about the area that we plan on mapping down here in the Grid Statistics box. You can see the flight distance and the number of images that will be taken, as well as the predicted ground resolution and a few other useful pieces of information. This information is going to help you to identify whether or not you will be able to complete this mission given your UAV's battery life. So for example, the Zephyr 2 flies for about 60 minutes, while the Zephyr 3 can fly for about 180 minutes. Knowing that the aircraft flies at an average of 10 meters per second at normal cruise speed and needs to fly a distance of 31 kilometers, given the approximate wind speed, you can roughly estimate how far you're going to be able to fly with your UAV given the desired flight mission suggested. As you become more comfortable using your UAV software and hardware, you'll get better at judging how far you will be able to go given the amount of wind that you have on that day. Also, the ground control software will tell you when you are running low on battery power long before it runs out. However, if you do run out of battery, you can always land in an automatic or manual mode in a clearing in your field, or if an operator is available, they will be able to take control of the UAV and guide it down safely for you. Depending on which payload you have installed on your Zephyr, you can check the camera here. So if you're running on the Zephyr 3, it's going to be the Sony Nex5 25mm camera, and from there, you can program the flight altitude that you want to fly. You can also see here that by adjusting the flight altitude, the number of flight swaths that you need to take will change. 240 meters will be typical for someone who is doing photo analysis. Now, you do need to comply with any applicable regulations. However, depending on the wind's direction, this would be something typical that people would use. As a rule, you'll always want to change the angle of your flight path with the wind's strength and direction in mind. If you want to fly the same mission in the same field at a later date, you can load the same flight path, but should always make sure to change the angle of the flight path according to the weather. I'll show you how to save and load a flight path in a little bit, but first I want to show you some more advanced options. So if you click on this checkbox here, you can see that these tabs appear. The first thing that you're going to see in the grid options is the amount of overlap. We suggest a 40% overlap for all of our payloads given that they are gyro stabilized. It will cut down on the amount of flight paths that you need to take. If you were using a stationary payload, we would recommend 60 to 80% overlap, but that's why we engineered our camera payloads to offer gyro stabilization. Also, your processing time will be cut down quite a bit when using a gyro-stabilized camera payload versus a non-stabilized camera payload, as there will be fewer images that it needs to process. Ultimately, the processing resources needed on the server that you're going to post-process your photo data will be reduced immensely given the cleaner data that the gyro-stabilized payload our UAVs come with offers. Now, if you have any experience with flying UAVs in the wind, you should already know that in most cases it is almost impossible to fly a UAV effectively with a stationary camera payload. So, most commonly, a 40% overlap should be chosen when doing photo analysis and flight planning with our products. In camera configuration here, you can adjust and add another camera. We don't recommend our novice UAV users to do this, but if you are a more advanced user, you can enter a different camera profile here and make it available through the normal camera profile options. Once you're comfortable with all the settings from this flight planning menu, you can click Accept and the flight path will be programmed into the flight plan here, and you're ready to go. As soon as you sync your UAV to the ground station, it will know exactly where to fly and when to take photographs. Now, depending on the wind speed for that day, the UAV will either have a little more or a little less time to hit all of the corresponding waypoints that it needs to hit. As each waypoint is met, a camera trigger response will be automatically given to the onboard camera while taking into consideration the programmed amount of overlap you specified during flight programming. Again, depending on how the wind is blowing on a particular day, the time needed to get to each pre-programmed waypoint will vary, with individual flight time not being a factor for triggering the onboard camera at the necessary points of reference. The system is designed this way so that crosswinds will not bump the UAV off of its required path, and so that all of the waypoints can be met regardless of the wind speed or direction. If you routinely adjust your angle of flight for wind direction on days that you are flying, over the course of several missions you will be able to generate a very tight set of photo data for analysis that can be referred to by your crop monitoring program, or for generating DEMs and so forth using Agrasoft PhotoScan Pro or Pix4D. Once you have programmed in your grid pattern, you're always going to want to program in a landing waypoint as well, so that you can perform an automatic landing. You'll want to pick an area somewhere where you know you have a clearing of about 100 meters and is free of trees or any other obstructions. The UAV will shut off its throttle once it gets close to the landing waypoint, and you can either automatically or manually stabilize the wings as the UAV carries out a belly landing. So let's say that we want to land in this area here. Right-click and select Land to create a landing waypoint, and you can see this added to the Waypoints menu at the left. The landing waypoint is programmed to disengage automatic mode entirely at 1 meter in altitude and do a belly land, as you can see. You can save this particular mission for flying on another day by going here and clicking on Save Waypoint File. You can delete a mission by selecting Clear Mission. We can also load another mission very simply. I'll demonstrate that for you now. So, as you can see, the same flight mission loads ready for you to fly without having to reprogram in any of the flight waypoints. All you need to do is adjust your flight angle to compensate for any wind, and you're ready to scan your flying area in exactly the same way as you did on the previous flight. So that's the general premise of programming a lawnmower pattern for flying an Autogrid flight mission. Another couple of options that may be useful to you as you learn how to fly is return to landing. Anytime you choose this setting while flying, the UAV will abort its pre-programmed mission and fly back to the takeoff point or initial UAV sync point. You can also do a few other things here. If you use the rally points command, you can tell the UAV to land at a predetermined landing area of your choice if there's ever a problem to where you would run out of battery power or would otherwise need to perform an emergency landing and cannot do so due to the UAV being too far from its initial launch point. I would suggest taking a look at the documentation for the Mission Planner ground control software for a more comprehensive look of how to use the software. I hope you enjoyed this video, and feel free to ask us any questions about planning an Autogrid flight mission by email or by phone. Thanks for watching, and happy flying!